So for this question, we're given this table, and we have a lot of blanks, and we're asked to find the missing data and then calculate what we would be willing to pay today for some security. We're trying to find the present value. Well, we don't know all the rates that we would use to discount all of those future cash flows back. That's exactly why we have to fill in this table. So let's do that first. So first, just to label everything that's in the in the header, all the columns, what they mean, R star is the real rate of interest. I is the inflation premium, which is just equal to the rate of inflation in that year. R sub n is the long rate, which is basically the return on an n-year bond. So when we think of a 10-year bond and we say it has a yield to maturity, say, of 10%, we're not saying that for sure the interest rate in each of the years 1 through 10 is 10%. We're saying on average that bond will give a yield of 10% in each one of those years. So it's more of like an average over a long segment of time, over several periods of time. That's what Rn, the long rate, means. Whereas Rf is the forward rate, and here these are 1-year forward rates. And so the forward rate is the single year that starts in some year. So Rf in the first row is going to be the forward rate, the 1-year forward rate that starts in year 1. Whereas Rf in the second row is going to be the 1-year forward rate that starts in year 2. So it's the interest rate between years 2 and year 3. So that's what the forward rate is. It's different than the long rate. So first let's fill in the average real rate, R star, information. This is easy since the real rate is the same in every year. So the average real rate, average R star, is just the average over all the previous years of the R star, the actual real rate in each year. Well, in year 1 the real rate was 2.5%, so the average was 2.5%. In year 2, the real rate in year 1 was 2.5%, and the real rate in year 2 was 2.5%. That didn't change the average, so the average is still 2.5%, and so on down the table. The average is going to be the same because none of those yearly real rates are different from each other. So the average is exactly the same as the actual. So now let's use the average inflation premiums that are given to find the inflation premiums in year 4 and year 5. So we're given the actual inflation that occurs in years 1, 2, and 3. We see the inflation in year 1 is 2%, the inflation in year 2 is 3%, and the inflation in year 3 is 7%. And in year 4, we see in the next column that the average inflation over the last 4 years was 4.5%, and the average inflation over the last 5 years was 4.4%. So since the average inflation in year 4 is 4.5%, we can find how much total inflation there was in the first 4 years. We just multiply the 4.5% average yearly inflation rate times the 4 years. That means there was a total of 18% of inflation in the periods between years 1, 2, 3, and 4. So all 4 years had a total of 18% inflation. Well, in the first 3 years, there was a total of 2% plus 3% plus 7% or 12% of inflation, which means in year 4 there must have been the 18% total that occurred over all 4 years minus the 12% that occurred in the first 3 years, or 6%. So we know that the inflation rate in year 4 must have been 6%. So we can similarly find the inflation premium in year 5. Since the average inflation in year 5 is 4.4%, the total amount of inflation over the 5-year span, again we do the same thing, 4.4% per year times the 5 years means over all 5 years there was a total of 22% of inflation. In the first 4 years there was a total of 2% plus 3% plus 7% plus 6% or 18% of inflation. So in year 5 that leaves the difference, 22 minus 18, or 4% left for year 5 to make that average 4.4. So now we have all of the inflation column filled up. Now that we have all of them for each year, we can easily fill in the average for the first 3 years. In year 1, the average inflation premium is the same as the actual inflation premium that occurred in that year, so it's just a 2%. In year 2, the average is equal to the amount in year 1, 2%, plus the amount in year 2, 3%, divided by 2, or 2.5%. In year 3, the average was the 2% in year 1, plus the 3% in year 2, plus the 7% in year 3 divided by 3, or 4%. So now we have our average inflation premium column filled out. So now let's move to the long rates. Well, we can think of R sub n as the average nominal rate that's earned each year. So Rn equals the average real rate plus the average inflation premium. So basically, this column right here is going to be equal to the average real rate, this column right here, plus the average inflation premium, that right there. And that's all we're going to do. We're going to move down the table and add each of those two components to give us the long rates in each year. So here's the formula. And for year 1, the long rate is equal to the real rate of 2.5% plus the average inflation premium, 2%, which is equal to 4.5%. In year 2, the average real was 2.5, the average inflation was 2.5, that gives us a long rate of 5%. In year 3, the average real was 2.5%, the average inflation was 4%, that gives us a long rate in year 3 of 6.5%. In year 4, it was 2.5% and 4.5%, giving us a long rate of 7%. And in year 5, we add 2.5% to the 4.4%, and that gives us a long rate of 6.9%. So that's a long rate for year 5. So if you were to buy a 5-year bond, then it would have a yield to maturity, an average rate, nominal rate each year of 6.9%. That's what that long rate means. Finally, we need to find the forward rates. The forward rate for each year is just the nominal rate of return earned in that year. So it's the sum of the real rate in that year and the inflation premium in that year. That means this column right here, the forward rate, is going to be equal to the actual real rate, this column right here, plus the actual inflation, that column right here. So instead of looking at the average columns, we're just going to be looking at the actual columns. So again, here's the formula. Forward rate equals the real rate plus the actual inflation premium for that year. For year 1, the forward rate is equal to the real rate of 2.5% plus the inflation of 2%, that gives us 4.5%. In year 2, the real was 2.5, the inflation was 3, that gives us a forward rate of 5.5%. In year 3, the real was 2.5, the inflation was 7%, that gives us a forward rate of 9.5%. In year 4, the real was 2.5, the inflation was 6%, that gives us a forward rate of 8.5%. And finally, we add 2.5 to 4% to get a forward rate in year 5 of 6.5%. So the forward rate, again, if we had a cash flow that occurred in year 5 and we wanted to find its value today, we would have to use the forward rate in each year. So we would have to discount from 5 to 4 at the 6.5% rate, the 5-year forward rate. Then we would have to discount from 4 to 3 at the 8.5%, and so on and so forth. So all of these rates only apply to the 1-year intervals in between years 1 through 5. That's exactly what the forward rate means. So we put that last 6.5% in our table, and it's complete. We have all the information we need. So now we have it filled out, we can answer the question. We need to find the present value of $7,500. Since we're assuming pure expectations, we can discount the amount back 4 years at the average rate, the long rate, R sub n, or we can discount it back using a different forward rate, R sub f, in each year. Like I was just explaining, the two are equivalent under pure expectations. So let's use the long rate because, again, well, this is just obviously going to be easier. We only have to use one rate. We can just raise it to the 4th power as opposed to having to use all of the different spot rates at different times. So the present value of $7,500 to be received 4 years from now is going to be equal to 1 to 7,500 divided by 1 plus the long rate in year 4 raised to the 4th power. And that's 7%, so we take the 7,500, divide it by 1 plus 7%, raise it to the 4th power. That gives us a present value of $5,721.71.